Yes. Okay. So yeah. Again, let's write the dates every time. Okay. And this lesson is lesson 2, and the topics we are doing today is first expressions. Then second is solving linear equation. Okay, and then from now on, when I write EQ apostrophe n, that is the abbreviation for equation. EQ apostrophe here. Okay, apostrophe n. Okay, is not invented by me, but we all math people do this. EQ apostrophe n is the short form or abbreviation for equations. Okay, so that, and then third is word problems. And fourth is linear equation in disguise. Okay, write those down, and then we'll go to the first topic. Yeah. Okay, so first is I want to write down some notes quickly. Is that well, actually, I'm pretty sure you all understand that math, but I want to make sure we know all the words so that when we communicate, it's clear. If we have some expression like this, maybe 3x squared plus 5y. So first you recall that 3x squared means 3 times x squared. Nothing in between actually means they are multiplying. And so by bad math says we multiply and divide first and then add, right? So here you should have this multiplying is one block first. This is one block. 5 times y multiplying is one block first. You do the multiplying first and then add them up. So the adding, subtracting separate the terms. So by bad math, adding, subtracting separate the terms. So here, this block is called a term. This block is called a term. Inside a term is made up of, so you can see maybe 5y, maybe 3xyz, or 2x squared. So those are each of them we call terms. Inside a term, we have some number at the front. It is called coefficient. And the letters are called variables. So each term has a coefficient and some variables. So again, some terms can be like, don't have to write down like 3x squared y, this is a term, minus 5x cubed, that's a term, and then 2xyz, that's a term. So each term has a number and some variable. Okay, yeah, so the letters are called variables. Okay, that's all. So just when I am talking coefficient, when I'm talking about term, you know what I'm talking about. Okay, that's that. And flip back to my first example. Yes, let's go to example 1. Example 1 is evaluate for w equals to 2. So evaluate means calculate until the end, if you recall. Okay, so a here is -4 plus w over w. Okay, so if it says w is equals to 2, then we plug in w is 2. If w meant to be 5, then we plug in w as 5. Yeah, quite straightforward. W is 2, so we just plug in w is 2. Plus w is plus 2. Divide by w is divide 2. Okay, so by bad math here, we should do the top first. That's -2 over 2, and then now we divide, that's 91. Okay, that's it, no problem. Okay, let's see B. B here, I have a W square plus 5W minus 16. Okay, so if W equals to 2, we just plug in 2. So here W square, while W is 2, then we just read 2 square. 5W, 5, 2 minus 16. Okay, so my question here is, well, here we speak 5W, right? But W is 2, so we just change W to 2, then we speak 5, 2. Is it correct? Well, 5, 2, yeah, exactly. I saw someone shake their head. 5, 2 is 52 with nothing in between. Although I said here nothing in between means multiply, but 3x squared, of course, is 3 times x squared. Between 5 and 2, nothing in between will be 52. So here we understand, as we mentioned here, this is multiplying. So 5W also means it's 5 times the W. So this is 5 times 2. Okay, then also now next, as we said before, by bad math, adding, subtracting, separate the terms. So it should be this is 1 block plus this is 1 block minus this is 1 block. Okay, so in one line we do this is 1 block plus 10 minus 16. Okay, then it is -2. Okay, anyone not done, type me a letter N, please. Remind you what I mean by done is you first understand it, and then like when I teach, you listen first, and then you copy. You can copy quickly if you understand it. Okay, let's go to example 2. Now, before I go to example 2, I want to remind you about simplifying, because the word associated with expression is usually simplify. The word associated with equation is usually solve. So here, the first topic is about expression is we know how to simplify them and we understand what each expression means. So now about simplifying, that I speak it last class, maybe I didn't write out. Here I want to write out about simplifying expressions. Okay, simplifying expressions. When you multiply and divide, you say to yourself number by number, x by x, y by y. If you have other letters being the variable, maybe sometimes we write 3abc, sometimes we write 2m squared n, sometimes we write 3xy, right? Xy squared. So if it's xy, it's xy by y. If it's mn, then n by m, n by n, or a by a, b by b, c by c. I will explain to you. You write it down first. Okay, if we are adding, subtracting, yeah, we speak to ourselves, collect like terms. So what I'm saying is that don't just do the question by the look of it, but actually think about what operation it is. Okay, example 2 here is just simplify. Okay, let's say this one. First one is 5x times 3x squared. Now, I said that when we are multiplying here in between, there is nothing. You all understand it means 5x the block, multiply 3x squared the block. If we are multiplying, we should do number by number, x by x. Okay. Okay, I want to explain why. So here, this is as always, by bad math, we have to get rid of bracket first, right? So let's try to get rid of the bracket first. Here, bracket 5x just means it's 5 times x. Nothing in between also means it's just multiplying. And then 3x squared, as we mentioned above, is just 3 times x squared. Okay, now next is, so everyone please copy everything. Okay, I know you know how to do it, but I want you to understand why that is. So here again, we are multiplying, all of them are multiplying. So in that mass, all the multiplying have the same priority, right? So you can do 5 times 3 first, you can do this x times this 3 first, you can do this x squared times the 5 first, you can do this 3 times that x squared first, and whichever way you do it, you just multiply them all. So I can do this as a 5 times 3 and then times x and then times x squared. That's why we can do just number by number. 5, 3 is 15. X times x squared is x cubed. Also, another thing is, as I mentioned, okay, as I mentioned last class, I mean, okay, x times x squared is in your head, you understand it was like a 1 of it here, 2 of it here. That's why you have 3 of them. Okay, so like if you see an x and an x, x and x, is it a 2x or is it an x squared? So think about the operation. Is it adding or is it multiplying? Okay, so here again, x squared is x multiplying 3 of them. Now, so in the notes, everyone, today, please write down the whole thing. But I'll write the gray, light gray arrow now, means that if later, anytime you have to write to me somehow, at our course, don't have to submit anything. But maybe, if, I don't know, maybe next semester I see you in L2B or I don't know, other class. So if you somehow need to maybe write your test to submit to me, you can write directly to it. So my gray arrow means that, yeah, in general, or from now on, I will also skip the middle 2 steps. I will just directly go from here to here. When you write to me, it's the same thing. You can just go from here to here. But for today's notes, I want you to write down the detail. Okay, so today's notes, please copy everything. So you understand what my gray arrow means. Okay, multiplying, we can do number by number. Dividing also. So next is, let's say we have something like 16x8 over 4x squared, let's say. Now I claim this is same as 16 over 4 times the x8 over x squared. Do you agree they are the same thing? Let's think about it. If we have to multiply fraction, we'll do top times top is the top, bottom times bottom is the bottom. Yeah, so it makes sense that this first line and the second line are the same amount, same quantity, same expression. And so indeed, in general, when we see a dividing, we can do number by number, x by x, y by y, a by a, b by b, if we have other variables. Okay, so number divide is 4, and then x8 divided by x2, you can think of dividing is subtract exponent. Or you can think of in your head is x8 of them, bottom have 2 of them, then you cancel 2 of them, then you have 6 left over on top. You understand what I'm drawing here? Yeah, so you can have this picture, then you don't have to spend the time of writing it out, but you can think of it in your head quickly, then you will not make mistake. So yeah, same thing from now on, we can just go straight from here to here. Okay, question C is 3x squared. Okay, well, we did it last time also, but I want to say the detail once again. Here, as we mentioned, 3x squared is 3 times x squared. So if the inside is multiplying, we can use the ABN rule. So remember, if they are multiplying, our exponent rules only works if we only have exponent rules when we are multiplying and divide. So if it's a plus b, for instance, we have no rule. Recall? These are multiplying, so we will do a has to exponent n, b also have to exponent n. So that's exactly what is going on here. The 3 has to x square, exponent 2 have to square, and the x2 have to square also. And so next time we can directly say to ourselves, 3 squared is 9 and x squared is x4. Yes, so next time we'll go directly to it. Okay, let me write D here. D is cubic root of 64x9. Okay, so this is actually also the ABN rule. Because what we have here is exactly AB to the 1/3. Then the A has two cubic root, the B also have two cubic root. So square root was the same rule, cubic root is also the same rule. When we have to root AB is root A root B. Cubic root AB is also cubic root A, cubic root B. So here we have cubic root A, cubic root B. Okay, now 64 is a small number. Maybe you all recognize cubic root of 64 is 4. But sometimes maybe or some teacher or when we get to higher level, we also want to understand, like instead of cubic root of 64 is just 4, we know it already because we know 4 cubed is 64. Okay, we can do that. Or another way to write things is we can write this as 64 1/3 x9 1/3. Yeah, actually, I mean, from here you go to this line or you go straight to the exponent version is also okay. What I was saying is that, yeah, you can write maybe, you recognize 64 is a 4 cube. This is a 64. And then to the exponent 1/3. Okay, so again, it doesn't detect my separate stroke. Okay, this is a 64 and then 1/3. Here by the ANN rule, you multiply them is 9/3. So you see, indeed, when we multiply, 3 and 3 cancel. 3 times 1 divided by 3. 3 and 1/3. ANN rule is that they multiply. Okay, so as we expect, that's just a 4. So again, actually, you can go straight to it since it's a small number. Okay, but later, sometimes some other questions, maybe we want to write this way also. So I just want to introduce that to you. Also here is that, yeah, if you can cubic root of x9, if you cannot do it right away, you think of this in your head. x9 and then over 3, so 9, 3 cancel, and it's just x cubed. Nothing in between, of course, means multiplying, so you don't have to write this dot, just 4x cubed. Okay, so E here is that 2. Now here, this is a fifth root of a cubed. So you notice I write a little bit of space in between. Okay, what I'm saying is this, if you squeeze them all together, okay, do you mean 2 to the 5 and then square root a cubed? Or do you mean 2 and then fifth roots of a cubed? They are not the same thing. So if you meant to be 2 to the 5, write it closer to the left side. If you meant to be fifth root, write it closer to the right side. So yeah, I purposely leave a little space in between so that we see it clearly. Okay, 2 times it minus 5a over fifth root of a square. Okay. Now there are some radicals. Previous class we wrote if it's radical, we do the same thing. About radicals, we also did that when we are multiply and divide. We do number by number, radical by radical. Last class we did that exactly, right? If we are adding, subtracting, we say to ourselves, collect like radical. That's just exactly like collect like terms. So here you don't see that they are adding, subtracting, and we don't see they are like radicals. So we definitely want to simplify it. But again, we only have something called exponent rule. Last class we said all the radicals, we can turn it back to exponent form first, then we can simplify. So yeah, let's turn them to exponent form. So this is a 3 over 5. That's a 5a over a to the 2 over 5. This one doesn't have anything to do. But this one is multiply and divide. So we set number by number, a by a, b by b. So number by number is just 5. And then collect the a is a to the 1. When you divide, you subtract. So 1 minus, subtract exponent. Sorry, I mean, when you divide them, you subtract the exponent. So 1 minus this 2 over 5. So here we have 2a 3 over 5 minus 1 minus 2/5 is 3/5. Yeah, so they are the same variable. They are like terms. Now about collecting like terms is this. Okay, don't have to write down what I'm going to write. So if you have 5a plus 2a, you literally can say it is 5 apples plus 2 apples equal to 7 apples. If you have 2b plus 9b, you can say the b stands for banana. 2 bananas plus 9 bananas is 11 bananas. If you get to something x squared, then you think of maybe x squared is just some more exotic fruit like pineapple, maybe. Okay, so it's the same argument. 3 pineapples plus 5 pineapples is total of 8 pineapples. So here is the same thing, although it doesn't look this here, the term doesn't look like it. But you in your head, you also think of just this is some whatever exotic fruit here, maybe mango. Okay, so 2 mango minus 5 mango. Okay. So yeah, is you can collect like term here is -3 of such term. Now, if this is a positive exponent already, so this is okay. Or if the question wants you to write it back to a radical form, so it depends on the question. The question will tell you write as what form, and I want the integer answer only, or I want radical answer only. You know, the question will tell you that. So if the question says you have to write it back to radical form, then we can write -3 a cubed 5th root of a cube. So I separate a little bit on purpose so that you see the 5 stick to the right side. Okay, so as I mentioned, no, again, and again, you see, no wonder. Collect like terms is exact same rule as collect like radicals because they are just the same thing. 3x means 3 times x, 3 root 5 just means 3 times root 5. So no wonder the rule is the same rule. If you did it in radical form, you will say to yourself, collect like radical. If you did it in exponent form, you will say collect like terms. Yeah, so they just mean the same thing. Okay, up to here seems good. So I'll wait maybe half a minute. You guys can finish writing everything, add some notes if you want to add some extra notes or what. Okay, anyone not done, type me a letter N, please. Okay, next is about expand and simplify. Now, usually, sometimes when we want to simplify, we want to expand and simplify, but sometimes we want to factor and simplify. So about example 3, I want to remind you this. Let's say that if we have 3a plus b, it means you have 3, what it means is that if you have a basket, You have 1 apple in it and 1 banana in it. You buy 3 of such thing. You buy 3 of the basket, like a gift set. If you buy 3 of it, now you open it up, open the bracket, means get rid of the basket. Then you just have 3 apples and 3 banana. So it makes sense that you multiply in is 3 of the A's, and then you have 3 of the B's also. So you notice when we multiply, when we expand, it corresponds to that we multiply it in. While factoring is the exact opposite. If we have 3a plus 3b, we will take out the common factor, divide out. So here, these are 2 terms. This is 1 term, this is 1 term, right? So we can look at what we can commonly divide out. In this term, we can divide out a 3. We can divide out a 3. This term divide out a 3, then you have a left. Plus this plus here. This term divide the 3 out, you have a b left. So factoring corresponds to divide out. Is the exact opposite. Okay, so when we simplify, when the question asks us to simplify, read carefully. Do they want us to expand and simplify or factor and simplify? Okay, here I want to do factor and simplify. What does it mean? Okay, let's see. Let's say we have 3c plus 5c, like 3 cars plus 5 cars. Of course, it's 8 cars. But if I want to factor to simplify it, is that same reasoning here, that this is 1 term, this is 1 term. This term is 3 times c, this term is 5 times c. So what is the common factor you can divide out? C is the common factor. We can divide out the c. You can divide out right at the back or right at the front, doesn't matter, because you write 3 here also means you have something multiplied by 3. Right at the front also means 3 times the bracket. So you might write it at the front or back, does not matter. Usually we like to write at the front, but front and back both means multiply. So I'll write at the back this time. This term we factor out the c, divide out the c, then we have 3 left. This term divide out the c, we have 5 left. So as we expected is 8c. Okay, so if we have 3x plus 2 minus x plus 2 is the exact same argument. This is 1 term minus this is 1 term because they are multiplying. You see here we have a plus. I said plus minus separate the terms. But then this is a multiplying, and here you have obviously 1 block because the bracket is very obvious. So you can see it's something times or something, then this is 1 term here. Okay, so in both terms, what is common? We can take out the common factor x plus 2. From this term, divide out the bracket, you have 3 left, minus this minus. From this term, divide out the x plus 2, then you have x left. So that's factoring.
Wait, I'm confused. How did you do that?
Okay, someone wants to ask something, or you just accidentally turn on your mic?
How did you factor that?
This one, B?
Yeah.
Did you understand A?
Yeah.
Yeah, so you have 3C. Think of this block as C. Oops. If you have 3c minus xc, won't you have just 3 minus x that many c? Just like this one?
Oh, okay. Never mind.
So again, right here, this is the common factor, x plus 2. So I write at the front this time that we take out common factor. Like here, they both multiply 3, then I can both divide out 3. They both multiply this x plus 2 bracket. So both of them can divide out this common factor, x plus 2. The first term divide out the bracket, then you have 3 left. Minus the second term, again, this is a term. Am I listening? Okay. This term, you divide out the bracket, then you have x left. Okay, everyone clear? Okay, so about fractions. Last class we wrote it. But I just write once again, adding, subtracting is common denominator. Even if they are not numbers. So question A here, I want to simplify 5x over x plus 2 over x squared over 3x plus 6. Okay, you can write the question first. You don't need to do it. I will do it. Okay, exactly. Maybe some of you can do it. Maybe some of you are like, hey, what the heck? 4 layers. What I mean by 4 layers is like this. 1, 2, 3, 4. Now, actually, since we understand fractions means top divided by bottom, so if you have 4 layers, 5 layers, 3 layers, 6 layers, wouldn't bother us. What I mean is, even if you have 3 layers like this, we just open it up as a top divided by bottom. 5 layers, 6 layers, we can do, all of them can work the same. So here, this 4 layer, we just open it up. Fraction means top divided by bottom. So now it go back to 2 layers, then we definitely know what to do. Okay, so dividing fraction is multiply the flip. Okay, do our usual thing. Multiply the flip. And then now the top and bottom relationship is multiply and divide. So we see if anything is, we can divide, then we can cancel it. So I see here x multiply x divide x squared. You can cross out 1x top and bottom. So I will cross out the 2 means 1x left. Cross out the exponent. Okay, anything else to cancel here? Does anyone see something? You can type me yes or no if you see it.
X plus 2 is 3x plus 6 is x plus 2 times 3.
Exactly. So what I was thinking to ask is that maybe I would expect maybe some people think 6 and 2 can cancel. 3x and x can cancel, maybe, question mark? No, they cannot. So again, if someone is wondering, here the answer is 3x and x cannot cancel. 6 and 2 cannot cancel either because they are not multiplying and dividing relationship. Here, maybe I'll quickly write this to you. Recall lesson 1, we wrote exactly this top and bottom thing. This top and bottom canceling was exactly correspond to multiply and divide. Right? So if you are not sure when you can cancel something, you can say this simple line to yourself. If you can factor it out, you can cancel. Because factor it out means you have a multiplying blocks. Okay, so here 5x plus 2, because the x I cancelled already. If you want, you can cancel them all at once at this line. So you keep the x here, keep the x squared there is okay, also okay. Okay, but I cancelled it already, so I didn't write it here. Okay, so 3x plus 6, you can factor it out. You can just factor it first. So now again, even without bracket, we know by bad math, this meant to be one block, right? So here, this and that is a multiply and dividing relationship you can cancel. So the leftover, top times top is 5, 3, which is 15. Bottom is 1x, which is just x. Is my writing too small? Okay. Yeah, no one responded me, but that's okay because no response means everything is okay. So I mean, if you can hear me clearly, you can see my writing, then you don't have to say anything. Okay. Someone said something. Euro can eat out when I think you meant can factor out. Okay. If you can, yeah, I meant factor. I forgot the word. Thank you. That's right. I forgot the word because I say it and then I just, if you can factor it out. Yeah, I meant factor here. Yeah. Thank you for reminding me here, everyone. I forgot to write the word. If you can factor it out, then you can cancel. Okay, anyone not done, type me a letter N. Okay, let's see B. So this one is just simplified fraction. Next is adding subtracting. 5 times S plus 1 over 4S minus 2 over 3S squared. So I chose 5 and S on purpose to tell you that please do your writing clearly, because some letters and number are very similar. 5S, for example, 6 and B, 2 and Z. So I just see sometimes the students misread themselves. Actually, sometimes I will misread my own writing also. Okay, so here again, write clearly for example. Another thing, okay, look up here, guys. Because I have seen some students did this before. 2 to the exponent x. And then because they didn't exaggerate the font size, next line it becomes like this, and the next line it becomes this. This is 2 to the exponent x. This is 2 times x. I have seen this kind of thing before. So please write, you need to, if something just squeezed together, just exaggerate your space and font size and like 5 and S. Okay, so yeah, that's it. And now we continue here, adding, subtracting common denominator all at once. Remember, yesterday last class we said, now I want you to build the common denominator just all at once. Number by number, this is supposed to be the lowest common multiple. So we do number by number, S by S. Number by number, 4 and 3 is 12. Now, 4 and 3 is that you multiply, you can get the 12, but not because you multiply them. It's indeed 12 is the lowest common multiple. So S and S squared, we are not supposed to multiply them. I claim that S squared is the common multiple already. As you see again in our head, 4S come to a 12S squared. What do we need? We need to multiply 3S only. So you see, S squared is enough. don't need to be s cubed. Bottom times whatever, top times whatever. 3s squared go to the 12s is bottom times 4, top times 4. Okay. I want to just move this a little bit so that it looks more space. Okay, so when you write to me, you don't need to write me the green. I want you to write to me in one line, you have the common denominator, and you tell me how you get the top. I mean, how you, like eventually you have a top and a bottom. So how did you get this top? It was that bottom times 3s top times 3s minus bottom times 4 top times 4. So when you write to me, I want you to write me one line is common denominator at the already, and tell me the top what to do so that I can get to this final answer. Okay, so now the top again, you are multiplying. So I think of just this is 15s, and then multiply to the x plus 1. I want to do it in one step. So this is a 15s. Okay, they multiply is 15s already. Multiplying it is 15s squared plus 15s, and then minus this 8. And then the denominator was this 12s squared. Now, is it done? Maybe some of you know how to factor quadratic already. Please record the first. Okay. What I was talking was is it done? So maybe some of you know how to factor quadratic. Now, what is the point of factoring? Is that if we factor it out, we can cancel, right? So if we somehow factor this, maybe you have a 3s blah 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 5s minus 4 plus 2. I just make it up. Okay, maybe you factor it like this. Well, then there's nothing to cancel anyway. So actually, whether we want to factor the top or not, we don't have to spend time to try to factor the top, because sometimes factoring the top quadratic is not as easy. Like it's not just 1 minute, that kind of thing. Maybe you take like 2 minutes to do it. Not that long, but maybe it takes 2 minutes. So do we want to waste the time to do that, or do the work to on it? Here we should understand that if I want to cancel a 12, is that if I can factor something 2 out, then here you can cancel, right? Otherwise, if you can factor out a s, then you can do cancel the s. So we just have to ask ourselves, you see, if we want to cancel, we can only cancel the 12 or the s. So can you take out a 2? Can you take out a 3? The 8s don't. Can you take out a 4? Can you take out a 6? No, you cannot take out 2, then you cannot take out 6, of course, because 6 has a 2 in it. Okay, so you cannot, even if you, what I'm saying is here is that even if you can factor the top, there is nothing to cancel anyway. So we don't have to spend time to factor it. So leave it like this, it's done. Clear? Okay, so you know when is the time we want to factor. Okay, last one, 3m over m plus 1, m minus 1, then minus 2 over m plus 1. Okay, I think it's very clear here. The common denominator is m plus 1, m minus 1. Okay, so 3m here. The bottom is already that denominator. Top here is in my head, I think bottom times m minus 1, top times m minus 1. This green thing is what I think in my head. So it should be minus 2 times m minus 1. Bottom is nicely factored. We don't touch it. the top is not factored, although we see some bracket here. A factoring means you break them into multiplying blocks. This is adding, subtracting, the top is not factored. So we have to expand and simplify. Especially when you subtract, you definitely need this bracket. -2 multiplied in here is a +2. So this is n plus 2 over n plus 1, n minus 1. Do we have anything to cancel? No, n plus 2 is already the simplest form, and the bottom is already factored. So nothing a multiply divide relationship to cancel. And that's it. Okay, anyone not done this page? Maybe I scroll down a little bit. Is it good? Okay, anyone not done, type me a letter N, please. Okay, so this session is done. Let's go to part 2, which is solving linear equation. Okay, example 4, 5. It's just solve it. Solve the unknown. Okay, so we start with something easiest. 2x plus 5 equals to 11. So I hope everyone recall that to cancel the +5, you -5 on both sides, so that the net effect is when you move the +5 over is the -5. Move the 2 over is the dividing 2. That's it. Okay, now I want to tell you, I don't know whether you are going to study math later, like higher level, university and on, but actually in your future math studies, even just up to grade 12, a lot of times you will see this. Your teacher will not tell you, but well, my teachers didn't tell me either, but I noticed this, is that a lot of times when we learn things, we learn just the basic type first, and then we learn if it looks a little bit different, we have to add one step of make it back to the previous look. So for instance, if I have something, I add one more step to it, will be like 3x minus 1 equals to 3x plus 9. Here, if we have no bracket, we know we just collect like terms, move all the numbers to one side. So if we have some bracket, is that we add one step of getting rid of the bracket first, then I can go back to the basic type. Okay, so let's expand and get rid of the bracket. And now, as we said, yeah, now we know. Oh, also, you remember, just in case you didn't know, the equal sign exactly means that the left-hand side and right-hand side are balanced. So it's like a scale here, left-hand side, right-hand side is balanced. So please line up your equal sign. That's exactly the middle of the balance scale. Okay, so I want to collect all the x on one side, move the 3x over is minus 3x. Negative 3 stay here. Negative 3 still sits on this plate. The 18 was on this plate. I want to move it over to here is minus 18. So that's 3x, negative 21. Move the 3 by dividing, and that's it. Okay, next is that I will add one more step. Now, actually, I mean that this is what we will learn a lot of time, a lot of type of questions when we go to higher level of math studies is that we'll learn the basic type. Then when the questions look a little bit different, you just try to change it back to the previous form that we know. Okay, I mean, this is also not only that this is what we learn, also maybe sometimes if you see some hard questions, difficult or thinking inquiry questions, maybe this is a technique also. Next, I add one more step is 5x plus 1 over 3 equals to over x equals to 3. Okay, so next I add one more step is that, yeah, as long as one line I know how to do it. What we see here is that even if we have something like this, 2x plus 5 equals to 3 minus x plus 5x minus 2, 5x minus 10, even if it's long like this, doesn't bother us. As long as it's one layer, we know how to do it. Just expand and collect like terms, right? One layer, what I mean is like this, just one layer like that, okay? As long as it's one layer, we know. So the problem is now if we have two layers, we just do one more step is get rid of the bottom first. So last class, we did that. My orange pen, again, orange pen is when we get rid of the fraction. Get rid of bottom is we multiply every term by common denominator. Here, common denominator is x. Remember last class, I have this orange pen also. So I can multiply just both sides by x. That's method 1. Now here also, I should remind you that, fraction is always bottom cannot be 0. So if you somehow solve x equal to 0, you have to reject it. X being 0 is not okay, because bottom is x. So the restriction for this equation is that x cannot be 0, because bottom cannot be 0. Okay, so when I multiply by, one thing is I can multiply by x, but now you notice actually, do we always have to do this our orange pen? When I mean, you see our goal is just to make it one layer. Actually, we notice here is that 5x plus 1 dividing x. Dividing, when you move over, is multiply. Then that's it. So either you do this or that, you get to the same line. You see, if you have x multiply in, they cancel. You have 5x plus 1. Here, multiply the x to this, you just have 3x. So you see, you think of it as multiply the common denominator, you get to this line. Or just actually, when you are dividing, you simply just move it over, it's multiplying already. Then you get this line also. Both of them is the same result. Again, what were we looking for is that this is one layer, no fraction, then we can do it. Open, kill the bottom, we go back to this type. Collect like terms, simplify, then we go back to the simplest type. Okay, so just add one step on each time. Make sense? Okay, so here I will collect 5x minus 3x, the plus 1 move over is minus 1. Negative 1, I mean, divide by 2, so that's negative half. Okay, that's it. Okay, everything clear? Anyone not done, type me a letter N, please, or anything unsure, ask now. Anyone not done, type me the letter N. Okay, so let's see D. Maybe I'll scroll up a little bit. So D here is x plus 1 over 2 minus 5 over 8 equals to 5x minus 2 over 6. Okay, here the bottom has no x. So whatever x you have will not bother us. Your bottom will not be 0 anyway. So we have no restriction for this question, no restriction for the x. every x is fine. And so we just get rid of the bottom. Here you cannot just simply move the 2 over, right? So yeah, we just do the same as before. Orange pen, get rid of bottom. Here, common denominator. Okay, let's see. Yeah, 2, 8, 6, they are small number. So you know it's 24. But, or we can do the same thing as, but we can also do the same thing as last time. 2 is a prime number, so I don't bother writing it. 8 is 2, 2, 2. 6 is 2, 3. So I claim the LCM is 2, 2, 2, 3. You have 2, 2, 2 right here, and you have 2, 3 right here. And of course, you have a 2 in it already. That's 24, exactly. Okay, so we multiply each term by 24. The whole thing times 24 again just means both sides times 24 so that left and right hand are still balanced on the scale. But when you multiply 24, you need to expand, multiply the 24 in. And so multiply the whole line by 24 means multiply each term by 24 and then they are still balanced. Clear, everyone? Okay, multiply 24 in, so 2 24 cancel, then you have a 12 times x minus 1. Multiply in 24 and 8 cancel, you have a 3 on top. Multiply 24, cancel, in the end you have a 4 on top to multiply this 5 and x minus 2. So again, you see, as I mentioned before, get rid of the bottom, then you go back to this type. Now you get rid of the bracket, then you go back to this type. So yeah, we just simplify. Okay, maybe I'll move it up a little bit so that it looks prettier. Okay, so yeah, let's simplify. 12x plus 12 minus 15 equal, you can see I try to line up the equal sign. Here I think of it as a 20 multiply in. So that's a 20x minus 40. Simplify a little bit. And then I collect like term, move all the x on this side, that's 8. Move all the number on this side, that's 37. So x equals to 37 over 8. Lowest form answer. Okay, fraction always in lowest form, and it is. So that's done. Yes, we do. I am just going to break now. Okay, so please don't be hasty. I have the time in control. Okay, finish writing, and today we can have 10-minute break, I think. So let's break until this time. You can go to washroom. If you want me to go back up, scroll up or left, you tell me. You can ask me questions also. Okay, so if you are back, you can turn on your camera. Okay, again, if you are back, you can turn on your camera. So Ryan, Lawrence, Leo, Zhang, Zhang. Lawrence, are you back?
I'm having some technical difficulties with my mouse.
Okay, that is fine. I just know you are here. Okay, that is fine. Now about quick notes, no, not notes, sorry. I mean, I just want to say this quickly, is that you don't have to ask me about break for other class, okay? Everyone, you don't have to ask me about break because I have like I have a schedule, of course, when I want to take a break and also and all that. But if you're like, why is it not break yet? I really want to go to washroom. Yeah, you can just ask if you want to go to washroom, you just tell me, then maybe I can adjust the break. Otherwise, I have a fixed time. Like I have a plan certain time to take to do the break. Okay, anyway, so back to this, everyone is here. Let's continue. So previous, we have done the second session. So now we do the third part, which is word problem. Okay, word problems, I will say that we should do 4 steps. First is let statements. Maybe you have heard of it before. Okay, if you haven't, what they are is like you let x be blah, 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 let y be blah, 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 blah. Okay, what is the point of doing that and what are they? Okay, now here I want to tell you quickly that in this class, I mean summer semester, you guys don't have to hand in homework, so I don't have to mark you anything. But in the coming September semester, maybe you will have to do homework and maybe the marker is the teacher, maybe the marker is some other TA. I have been a marker in university before, so I want to tell you, like sometimes you think you understand everything. I mean, you think, why don't you get the mark? Or I just want to tell you, I have been a marker before, so I can tell you some techniques to get the marks. When you are writing paper, you write 1 only, but your teacher marks 30, right? For 1 class. But I have even, here in the summer, I'm teaching 5 class. So I'm marking like 80 people if I mark. And actually in university, first year calculus, maybe it's around 700-800 people. Actually, U of T have 1,000 something people for first year calculus. So yeah, if you write 1, I mark 8,000, or you write 1, I mark 1,800, so 800 or 1,000. Well, of course, I'm not the only person who marks, so we have a few people share the job, of course. But anyway, I'm just telling you that, yeah, you see, if a question is out of 4 marks, let's say you write 1 and I mark 8,800, so I will not read every line you write. On the other hand, if the question is out of 4 marks, actually we have guidelines about certain parts you write, then you get a mark. So I'm telling you that, yes, if you want to here, sometimes again, our course don't have to hand in homework, but in the coming September, maybe you're going to take L2B or level 3 or level 4 or whatever, you are going to submit homework. The marker might not know who you are. So if me is marking your work, I'm the teacher. So in the class, I see usually Ryan, let's say Ryan's on the top. So Ryan is doing quite well in the class. So I know, okay, here Ryan should be just being careless. So if he missed 1 word and all that, okay, fine, I'll let him pass by, maybe. Or maybe like another person, and Sammy, I don't know, I just make this one up. Okay, Sammy is usually in the class, I already can tell he don't understand anything. He is not following. So in the homework, he's writing scribblish to me. Then I know, okay, yeah, he is just randomly giving me random things that not that he is careless, He just don't know. So if I know you, I can, maybe judge you by that. But if the marker don't know you at all, he or she only judge you by your writing. So your logic should be that I write clearly for the marker to give me mark, instead of, well, she is the teacher, how can she don't understand what I'm writing? No, you cannot assume we understand you. It should be that you write clearly so that the marker give you mark. Okay, so yeah, your logic is not like, well, here, well, of course I know this, you are the teacher, how come you don't know? No, it's not like that. I know, but I don't want to assume you know. What if you are just copying from something on the website, right? So I don't want to assume you know. Anyway, come back to this now. So yeah, I want you to write out these 4 steps. Is that you should eat. Again, our class here don't have to submit anything, but if you ever have to have any homework, you should write out the full solution. Is these 4 steps. Okay, so let statement again, you have to write clearly to the reader, which is the marker. So if we are solving, you see in the examples before, we are solving x and y, right? Solving x and all that. So what the heck is x? So you have to write out what x are. So official reasoning of writing let statement is that you have to let the reader know what your xy mean. So let x be blah, 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 let y be blah, 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 blah. That's the official meaning of it, or official reasoning of it. That's what your teacher is going to tell you also. That's correct. That's the official reasoning. But on the other hand, now how about we are on the student side? Now, as a teacher, I have seen a lot of students who don't know how to do certain questions. It was because they wasn't even clear what the question is asking for. So actually, as a student on our side, we should first understand what the question is asking for, and exactly whatever we want, we will call them xy because we solve xy, right? So whatever we want, we call them xy. So the unofficial reasoning of let statement on our side is that we should identify what the question is asking for first. Okay, so again, whatever the question is asking for, we call them xy. We set up some equations, then we solve the xy. So next is we have to set up some equations. Maybe 1, maybe 2. So bracket S is like maybe more than 1. And then we have some equations, we just solve them. If it's a word problem, at the end we have to answer, therefore there are 2 apples, therefore there are 5 trees, that kind of thing. So lastly is answer it, write a therefore statement. Okay, so they are the logical 4-step what I call by. Because actually some school teacher will give 7 steps, which include 1 step you have to draw the diagram first. Now, so you see, I say you don't need to draw a diagram because if since we need to understand the question, if we need to draw a diagram to understand it, we'll just draw it for ourselves. So I didn't think drawing diagram is one logical step. It's because if we need it, we will do it. So that's what I mean by 4 logical steps. First, understand what we need, set up equation to solve it, solve what we want, then answer it. That's it. Okay, so that's example 6. Okay, word problem, I can type it out. So I'll type it out here. Like this big maybe. Okay, so 2 times the number is 5 less than triple the number. What is that number? Okay, that's it. Just a short question. Okay, so as I said right here, the first step is understand what we are finding. Okay, so we want what is that number? Let's call that is exactly what we want. So we can call it x, actually we can call it A, B, C, D, E, F, G, whatever letter is fine. So let me just use n stand for number. What I want is that number. So the first step is let n be the number. That's what we are solving. Now, if we have one unknown, we are supposed to set up one equation. If we have three unknowns, we'll set up three equations to solve. One equation is that must be given one piece of information that we can have one equation. Here exactly, we only have one piece of information. It says 2 times that number is 5 less than triple the number. Okay, so 2 times the number is 5 less than triple the number. So triple the number and then 5 less than it. So this is the English sentence. And this is the algebraic sentence. But the algebraic version, this is the English version. This is the wording version. And here is the algebraic version. They are the same sentence, just one in English, one in math. Okay, so yeah, one unknown, one equation rule. Let's just solve it. Move the 2n over, move the -5 over. Actually, it's just done. That's it. And it's 5. And what we want is the number. So therefore, the number is 5. Okay, that's it. Okay, B here. Sam is 12 years older than Tom. 3 years ago, Sam was 7 times Tom's age. How old are they now? Okay, yeah, just make it 2 lines of space like this. Okay. How old are they? That's what we want, their age. So let me use S stand for Sam, T stand for Tom. Now, but age is the thing that is not the same always, because n here is just n is 5, satisfying this condition, n must be 5. When you talk about age is that, you know, this year you are 12 years old, the next year you'll be 13. And 3 years ago you were, if you are 12 this year, 3 years ago you are 9. So age is something that you have to specify. When are we talking about? This question is talking about now. So I want to write specifically, yeah, S stands for Sam's age, but Sam's age now, not 2 years later or not 3 years ago. You know, sometimes they ask you, how old is Sam 5 years later? Then you adjust the number, right? So specifically, I'm solving the age now. Let S be Sam's age now, and let T be, so if I haven't mentioned this before, this symbol is called ditto. Ditto means that you just, it's the same as the word above. So let T be Tom's age now. Okay, so this is not invented by me. All math people and even English people do this. So but if you have certain teachers say, okay, no, you cannot do that. You have to write out the full sentence. Okay, for that teacher, then you do that. But if you go to get up to university, then we all don't care for sure. We all know just we can write like this. Okay, anyway, so we have 2 unknowns here. Then we should set up 2 equations. Did we have 2 pieces of information? Yes, exactly, we do. So again, you need to set up 5. If you have 5 unknowns, you will expect that they give us 5 pieces of information to set up 5 equations to solve 5 unknowns. Clear, everyone? 2 unknowns need 2 equations, n unknown need n equations in general. Okay, first piece is right here. This is quite easy to do. This piece of information. about age is different every year, but Sam is 12 years older than Tom. Actually, it doesn't bother us because you think of you are 3 years older than your younger brother. Now you are 3 years older than him. But when you are 30, you are still 3 years older than your younger brother. Even when you are 60, you will be still 3 years older than your younger brother. So no matter when it is, Sam is always 12 years older. So Sam, you can use the letter now. Sam is 12 more than Tom. Now it's true. 3 years later is true. 10 years ago is also true. That's the first piece of information. Second piece is that 3 years ago, Sam was 7 times Tom. Okay, 3 years ago. Now exactly. Sam is S this year. I claim that 3 years ago, Sam must be S minus 3. Do you agree? So similarly, Tom must be T minus 3 also. So about the condition, Sam was 7 times H, 7 Toms. Don't write S equals 7T. Okay, not true. This is not true. Don't write it. Okay, it was 3 years ago, Sam is 7 times Tom. But 3 years ago, Sam was S minus 3 and Tom was T minus 3. So as I mentioned, 2 equation, 2 unknown. Here, this is our first equation. This is our second equation, exactly. So all match up, all fit nicely. That systematically is 2 equation, 2 unknown. Okay, so what we have been solving is 1 equation, 1 unknown. Okay, you see here, I'll go back to that page after, don't worry. Okay, you see one equation only have x in it. One equation only have x in it. The whole equation only have x in it. So 1 equation can deal with 1 unknown. If we have 2 equation, 2 unknown, we will do substitution or elimination to make it back to 1 equation, 1 unknown. So here, S is isolated, I'll use substitution. The S block is equals to this block. So this S you can sub into here, then we can make 1 equation, 1 unknown. S being 12 plus T. So when I read this line, S minus 3, I'll write S, this is S. Everyone, S minus 3 equal 7T minus 3. This is S. So you see, when we do substitution, okay, then we make it into 1 equation, 1 unknown. Okay, then the rest is all clear. Collect the T on this side, collect the numbers on this side. After we find T, we find S. S is right here, 12 plus T. So while the T is 5, then S will be 17. Okay, so we easily answer it because you don't have to go back to X stand for what again. Just use the nicer letter, like more convenient letter. S is Sam, T is Tom. So Tom is 5 years old. Now, and Sam is 17. 17 years old now. Of course, when you say I'm 5 years old, I'm 35, then you just said you are 35 years old, for example, right? I'm not 35 years old. I'm older than that actually, but okay, not that you care, but just Sam is 17. I think we all understand means Sam is 17 years old. Okay, so I'm saying that, okay, I don't need to care about grammar too much because I'm not English teacher. Everything clear here? Anyone not done? Okay, see, let me squeeze it in here. Use this much space. So okay, one sec, sometimes nickel together worth 80 cents. There are 5 times more than nickels. How many of each coin are there? Okay, that's the question. And someone says something. Go to washroom. Yes, go quickly. You don't have to turn off your camera. Just go. So I'll wait for 2 minutes for people to write things down. Okay, I lied. I will not wait for 2 minutes, but just wait a little bit. Hopefully he come back soon. That you guys can finish writing whatever you didn't before. Okay, so let's see. Yeah, I see you. Okay, so how many of each coins means like we want to find out how many nickel coins, how many dime coins. So let's use N stand for nickel and D stand for dime. Okay, so the first step is, now don't just say N stand for nickel. As you see here, S stand for Sam, yes. But sometimes the question asks for Sam's age. Sometimes the question asks for Sam's height. Sometimes the question asks for Sam's money. How much money does he have? That kind of thing. So write out not just N stand for nickel, but N means how many nickel, number of nickel. Okay, so let N be number of nickels, means like number of the coins, number of nickel coins, and let D be number. Okay, he doesn't detect my separate strokes like this. Okay, let D be number of times. Okay, so we have 2 unknowns again, then we should set up 2 equations. And we need to squeeze out 2 pieces of information then. Sometimes it's not as straightforward. And here you see, I just throw it right in front of your face that you have 2 pieces of information. But sometimes you need to squeeze them out. So I hope you understand systematically. 3 unknowns must be 3 equations to solve. So there must be 3 pieces of information, but sometimes they are not apparent. You need to squeeze them out sometimes. If you expect there are 3 pieces, then you know you need to squeeze them out. Otherwise, you will just forget about it if you don't know. So that's why I want to tell you, you know that you need to squeeze it out sometimes. Okay, so here again, first piece, some dimes and some coins together worth 80. Okay. Each dime worth 10 cents together. Did I spell it wrong? No, okay. So yeah, each dime is 10 cents. So if you have D dimes, it should be 10 cents times D. That's how much money it is. Okay, so if you have D dimes, 0.1 D, I'm doing in terms of dollar. 10 cents is 0.1 dollar. Okay, nickels is a 5 cent. So again, if you have 1 nickel, 5 cents, 2 nickels, 10 cents, 3 nickels, 15 cents, N nickels is 5 cents times N, that much money. So if we have N nickels, how much they worth is 0.05 N. And together, the money you have is 80 cents. Now I'm doing in terms of dollar, but some students said before that they want to do it in The cent is also okay. So you can put 10D, 5N, 80 cents. That's also okay. All right. Second piece of information, 5 times more than nickel. Okay, this one is very straightforward. Number of times, 5 times more. So you have 5, time is 5 more than N. Those are the two equations exactly. So two equation, two unknown, perfect substitution or elimination. Here are this D is isolated, so I'll sub this D in, while D being this block. Okay, so when we solve, we do substitution, solve the D in, sub the D in, 0.1 D, 0.1 D, 0.1 D plus 0.05 N equals to 0.8. So I speak 0.1 D, but I write this as D. Again, you see here, we know we are on the right track because we get to one line, one unknown only. One equation, one unknown. Okay, the rest is clear. Then we just expand, simplify. Okay. Collect the ends. Here you have 0.15. Move the 0.5 over, you have 0.3. So n equals to 0.3 over 0.15. Divide. When you all know how to divide decimal, is make them to whole number, right? So this is 30 over 15. So that's 2. Okay, if we have two unknowns, after we find x, we have to find the y also. So here, after we find n, we have to find d also, just like here. After t, find s. So here, after n, now find d. Okay, d is right here, it's 5 plus n. While n is 2, d will be 7. While n is 2, then d will be 7. If n is something else, d will be something else also. Okay, that's it. And also now, one more thing to say is that you notice that our answer is reasonable. Because nickel, you cannot be 1.5 nickel. Like a nickel, each nickel is a coin, right? So you can have 1 coin, 2 coins. You cannot have a 3.6 of a coin. Actually, you cannot have negative 2 coins either. So here the number makes sense is that this is a positive whole number. If you got somehow 3.5 here, it doesn't make sense that you did something wrong probably. Okay, so here, yes, they make sense, just 2 coins and 7 coins. So there are 2 nickels and 7 dimes. This is the therefore statement. Officially, some teacher write that therefore statement. Okay, so I'll write this therefore symbol to you also. Okay. Everything clear? Anything to ask? Ask now. Okay, anyone not done, type me a letter N, please. No one. Okay, so we get to the last part already. Is linear equations in disguise. Okay, first let's understand what linear means in the linear equation. Linear means degree 1. Means that in the equation, both x and y has to be exponent 1. The degree of a term is the sum of the exponents. So you see all of we have done linear equations before, right? Part 2 was linear. So for example, this is a degree 2. This term is degree 2. This term is degree 1. Clear, everyone? Okay, the exponent 2 here is degree 2. What if you have something like this? 5x, y, z. This is a 1, 1, 1. Then together, this is a degree 3. Okay, so you see again that what we have been doing, they are always, when we did linear equations, they are always x to the 1, x to the 1, x to the 1, x to the 1, right? So yeah, we have been doing linear equations. Now, so linear equation in disguise means, just in case someone didn't know the word disguise means you are putting on a mask and pretend to be something else. So like if you are wearing, I don't know if you guys know Naruto, maybe this animation is not your generation. I don't know what Pokemon. Do you guys still know what Pokemon is? So maybe you wear Pikachu's mask, then you pretend to be Pikachu. So you are disguising as Pikachu. Okay, so that's what disguise means. So linear equation in disguise means like they pretend or they look like something else, but actually we can still solve them as linear equations. Okay, so let's do it. That's example 7. Just solve each. Just solve them. Okay, so A is 3 root x minus 2 equals 30 minus root x. Now, maybe some of you see already how we can solve it as a linear. You just see it. It just look automatic to you. Great. Otherwise, officially, indeed, this is not linear because root x is x to the half. So no wonder, officially it's not linear. But we just solve it like linear because we can think of this block is just A or Y or N, whatever you call it. So we can still just move it over, collect like term, that kind of thing to solve it. Just like solving linear equation. So yeah, that's what we are going to do. Move it over. This, you have 3 of such block. Minus 1 move over is plus 1 block. 30 was sitting on the right side plate of the scale balance. Minus 2 move over is plus 2. So 3 of such block plus 1 of such block, you have 4 of such blocks. And so the rest is easy, just divide by 4. How to cancel the x square root? Square root is you square, then you cancel. So you move the square root over, it's become a square. Just like you move a multiply over is a divide. Okay, move a square root over is square. So x equals to 64. Okay, B, 3 over x minus 2 equals to 7 plus 2 over x. Okay, so this is it doesn't look like anything special here. Isn't it just kill the bottom, that kind of question? That's right, you can do it that way. So now, first of all, I've officially, maybe I'll remind you here, bottom cannot be 0, so here x cannot be 0. So again, if you somehow, you are solving here, somehow you get x equals 0, it's possible. But if this question get x equals 0, you have to reject it, because bottom cannot be 0. Okay, officially, it is not linear, although it looks like x to the 1, but actually it is a 1 over x. 1 over x is x to the negative 1. So you see it's not linear by definition. But we can solve it like linear. Or even, just as we said before, why bother? Don't we just do the same thing, get rid of bottom? So my orange pen come again, get rid of bottom. Here, common denominator is just x. Common denom means common denominator, I'm just lazy. Okay, common denominator is x. Yeah, just multiply the whole thing by x. Great. X multiply in, they cancel, so you get a 3 here. X multiply into this, you get 2x. X multiply into this term, you have 7x. X multiply to this term, they cancel, and you get a 2. Okay, the rest is clear. Move the 2 over, it's 1. So x equals to 1 over 9. Okay. Well, since I wrote method 1, of course, then I have a method 2. Is that I want to solve it the linear method. So how do I solve it as a linear? Is that you recognize 1 over x is the block. So let method 2 is let a be 1 over x. As you notice, 3 over x just means 3 times 1 over x. So you can write as a 3a, for example. Okay, so here 3 over x can be written as a 3a minus 2, 7. Similarly, 2 over x is also 2 times 1 over x, which is 2a. So you see, even if it's 1 over x, we can just think of it as like a block. Okay, so here is 9, here is a equals 9. But a was 1 over x, so lastly, put back that a is 1 over x. So move it over. I mean, if you want to move the x to the top, then you move the 9 to the bottom. Okay, so they are the same answer, of course. Okay, so this method will be like this one, that you think of the non-linear term as just some a block. Then you can just collect like term like the linear way. Okay, so again, x, as long as x is not 0, any x you get is fine. So here x being 1 over 9, this answer is we can accept. Okay, anyone not done? Type me a letter N, please. Okay, question C. Here, cubic root of 2z minus 1. So write your 2 and z carefully. 2z plus 1, sorry. Okay, and minus 5 equals to, not equal, sorry, plus 2. Cubic root of 2z plus 1 equals to negative 14. So again, you see, I write a little bit space in between to indicate that the small little 3 is toward the right side, stick to the right thing. So it's a cubic root, not a 2 cube. Okay, I think you can tell this obviously is not linear, right? And you can tell this is the block also, obviously this is the block. Okay, so we just do it the linear way, is like collect like terms. So here you have a block and plus 2 of such blocks. So together you have 3 of such blocks. And the minus 5 move over here is minus 9. Okay, divide by 3, and then we just solve it like usual. open up the operations one by one, unwind the operations one by one, like untie your shoelaces. Shoelace, if you have a lot of knots on your shoelace, you untie the outermost one, right? You're starting from the outermost one to untie each of them, right? So we open up from the outermost operation, which is move the 3 over, is divide. Now you move the cubic root, sorry. So same as before, moving the cubic root is to cube both sides to cancel it. So move the cubic root over is a cube, just like when you move a square root over is a square. Moving a minus over is the add. Minus 5 over is add 5. Cubic root here, move it over is exponent 3. So here we have 2z plus 1, negative 3 cubed, it's just negative 27. Okay, the rest is very clear now. Okay, d x over x minus 1 plus 2 over 3 equals to 2 over x minus 1. Okay, before I say whatever method to do, can you all tell me what is the restriction on x for this equation? For this equation, what x cannot be?
X cannot be 1.
Exactly. You can just type on chat instead, please. Everyone see it? X cannot be 1. Because if you plug in 1, the bottom will be 0. That's not okay. All right. Now next is, well, here you have a 1 over, but you have an x on top also. So I don't want to call this 1 over thing as an a. Well, then actually we can just stick with the usual method. It's just get rid of the bottom. The same thing here. Common denominator is 3 times x minus 1. Okay, we have 3 here. So to kill the bottom, multiply each of the term times 3x minus 1. Okay, so multiply this into this term, x minus 1 cancel, you have a 3 left. Everyone see it? Multiply the 3 in, 3 cancel, then you have x minus 1. This multiply in, x minus 1 cancel, then you have a 3 times 2. Okay, one layer, you kill the bottom, one layer, then we know, just expand, collect like times. Okay. Here, collect is 5x. Collect all the number on this side is 8, so x equals to 8 over 5. Okay, so anything unclear? Anyone not done, type me a letter N, please. Okay, so lastly, let's do one try question. So maybe I'll call it example 8, which is a try question. Okay, I'll type it out because it's a word problem I meant to do. Okay. So here, Joanne can't quite read the board in her math class. She writes down the equation she reads on the board. which is 3x minus 7 equals to 38 minus 7. Yeah. She correctly solved the equation. She wrote down. But she is surprised when she sees the teacher's answer is not the same, but is surprised to hear the teacher say the answer is 6 less than the answer she has. When she asked the teacher to check, the teacher says that Joanne copied the coefficient of x incorrectly. Okay, but everything else is correct. Okay. Yeah, I just want to make it like this. Okay. So what should the coefficient of x have been? Okay, so please write down the question. Don't just give me the answer. Yeah, you can give me an answer when you get it, but also write down the question. Because after 2 weeks, when you review, you'll be like, what the heck is this question? Suddenly there is a number floating around. So you all write down the question and you do it. If you get an answer, you type on chat. Okay, other people? So look, this class should be okay. Okay. Some people got a different answer. Okay, so let me take it up now. Okay, so I want to remind you that when you write your solution, you have to write clearly. We shouldn't write things floating around. So yeah, we just write out Joanne gets some answer, but the correct answer is 6 less than her answer. Let's see what her answer is first. So Joanne's equation is 3x minus 7 equals to 38. So 3x equals to 45, x equals to 15. That's Joanne's answer. But the correct answer is it was 6 less than her answer. So it should be 15 minus 6, which is 9. That's the correct answer. Okay, then now the correct equation should be this. The coefficient of x is wrong, so it wasn't 3, but it's something else. Let's say it is K. I just make a letter for it. So you want something like Kx minus 7 equals to 38, while x equals to 9 is the solution. So you know that if a solution means that it satisfies the equation. So if we plug in 9, 9 must satisfy the equation, then we can find what K is. So we have, when we sub in 9, this equation must be satisfied. So what should K be? So here we have 9K, move the minus 7 over is 45, divide by 9, so K is 5. Yeah, that's it. What should the coefficient be? The coefficient should be 5. Okay, that's it. Okay, so everything is done today. If you are done writing down everything, you type me a bye, then you can go. So I'll see you tomorrow's class, tomorrow homework class, or Friday's class. Okay, bye, bye, bye. But if you are not done, you can tell me to scroll up, down, left, right. Anson Wu, are you still here? Rachel Dong, are you still here? Anson Wu, are you still here?